Good afternoon, good evening, good afternoon, good morning, whatever time you are watching this. We are starting this week. We are focusing. We have an exam, but you know, exam is on Monday, and you should be start pay attention to chapter 4, and that's what we're gonna be focusing: the notion and the concepts of forces, the three laws of Newton, and finishing up defining friction, what friction exactly is. Um, Briefly, here are some recommendations besides Khan Academy. So you go to Khan Academy, khanacademy.org right here, and then you select subjects, and then you select science, physics, and here forces and Newton's laws of motion. All these lectures are very good, and you should play around with it. I know there are a lot, right? And so you have different situations, friction, tension, and we'll talk about it in a second. Okay, so this is a good resource. You should use it. Another resource, you go to compadre.org, www.compadre.org, and you look for physics classroom. And then you have a lot of resources here, and what we are there you go. So what we are focusing now is physics classroom tutorial. So click on it, and here it is: Newton's laws and motions and forces in 2 dimensions. So start with this, Newton's law, and then you have the same thing as we saw in Khan Academy: Newton's first law, the definition of inertia, masses, and things like that. Good resource. So in our book, we have 1, 2, 3, 4, 5, 6 sections to go through, and section number 1 defines physically what force is. What's the definition of force? Explains the 3 laws of motion, Newton's first law, second law, third law, and has some applications. Section 4.5, and the definition of friction. So let me try to summarize all of this for you. So far, oh wait a second, I don't have my pad on. Okay. So far we have built the notion of acceleration, and we have also built the notion of velocity, right? So imagine a situation of a block that is moving in one dimension, in one direction, saying just in X direction, just to make it simple, and is moving to the right with a given velocity. Okay, and at this time, just for assumption, let's pretend it's moving to the right with a velocity that is constant. It's constant. So how can we visualize this? Imagine, for instance, a car that is moving, so has little wheels in there, and it moves 65 miles per hour. So the velocity is constant. Why is that? Well, you have some friction in the floor. I'm not gonna go in detail now, but there is some air resistance. There is all kind of things going on, and the car is going in a straight line, 65 miles per hour, because the engine, you are burning gasoline, and then you have a thrust in the car that forces the car moving forward. So we have something going on. One is you have some engine, some technology that allows you to have your car moving forward, and at the same time you have some contrary, some resistance to that motion that is caused by perhaps the pavement is not so smooth, and perhaps you have a lot of winds, but you are able to keep that speed or that velocity in a constant way. So what if suddenly there is a big cow right here? It's a cow, right? In the middle of the road is a big tail, and the driver sees the cow, and the driver is forced to change its states of motion. There are some bad things going to happen, right? So when the driver changes the state of motion, which means attempts to go from 65 miles per hour in the forward direction to 0 miles per hour, you really want to stop. So the driver has to do something in the car for that to happen. The driver has to call upon the actions of some external force on the car so that the car can stop. So force, what is the definition of force? Force is something, is a physical quantity, that what the force does, it changes the state of motion. I could state this in a different way. Change the velocity. And velocity, remember, is not just speed, is speed and direction. Change the velocity on a time interval. And technically, what we are going to learn in Newton's first law, the second law, as we're going to see in Newton's second law, force is a vector. Force is a vector, and whatever external force is used to change the state of motion, that is going to be proportional to the change of your velocity over a certain time interval. And the change of velocity over a certain time interval is called acceleration. So, stating briefly, this is a key equation, equation in our course, is that if you have a model going with a certain velocity, that velocity is going to be changed over a certain time interval only and only if some net external force is applied to it. And the magnitude and direction of that net force is proportional to what we have been studying as acceleration. Okay. Let's now try to list the type of forces you're going to see playing in this course. So you have a surface, right? And you place a block on top of it. So one of the basic forces that probably will appear in most of your problems is the one caused by the attraction of Earth to any object that happen to be around it. And that force is called gravity force. And this force is proportional to G, to acceleration of gravity we studied in chapter 2. So we saw in chapter 2, even in situation of projectile motions or situation of free fall, let's depict here projectile motion type of situation. At any given point of this trajectory, G always is pointing downward, always like this. So therefore, this force called gravity will be always be pointing in a downward direction, in a vertical direction, and facing down. So if I were to represent this force acted on this block, here it would be. So you have the gravity force, which is equal to m times g, which we found as being 9.8. Now the unity of force, Newton, the unity of force. Now the block is standing on a surface. So the surface is now supporting, is holding the block up. So the surface exerts a reactive force on the block that's called normal force. Normal force. So normal force sometimes is depicted as Fn, sometimes as N. So let me write down the forces we are learning here. One is gravity, or the weight of their body. And gravity or the weight has an absolute value, mg. The second force is normal force. So normal force is one that happens to be always applied perpendicular to the body you are studying, and implies there is contact between the body and the surface you are studying. So let me show examples of normal force in action. Here are some examples right here. Another example, I have a wall, floor, and I have somebody that's leaning against the floor. It is the foot, it's a little tummy, this is the butt, and the head, right? Somebody is, you could be more graphic, so that person is not feeling well, it's kind of throwing up. That's disgusting. But anyway, so this person is leaning against the wall and is being supported also by the floor. So we have a funny situation that you have two contacts, and if you're studying the person, if you're studying the body as being the person, so what are the normal forces acting on the person? Well, I have one that comes out of the wall to the person, perpendicular to it, F and 1. And I have another one that is being acted from the floor on the foot of that person, which I'm calling F and 2. So there are two normal forces, different because, again, normal is always perpendicular to the body in contact, right? Another example. I have a inclined plane and I have a block on it. So there is a normal force this slope makes on the block, and this normal force, as you are studying, is always perpendicular to the block. There you go. Perpendicular means makes an angle of 90 degrees with the floor. See that? So here is my normal force. Okay? So weight, normal force. Another type of force you're going to see a lot is tension force. Tension force. So tension force is a force that acts through a cable to a string, and here's an example. I have the ceiling, and on the ceiling I have a cord connected to it, and this cord is holding on a block. So what are the forces acting on the block? Well, I do have a tension force for sure, and I symbolize it by T. So the tension force again runs through cable or string, and in this situation here it holds up the block. If the tension force is not there, the block will fall because of what? Because of its weight, because of its gravity force, Fg. So in this situation I have a tension and I have a vertical downward gravity force. Now in this example here I forgot to indicate, because I didn't want to indicate at that moment, the gravity force, which is always vertical and points down, that is acting on the block. So normal force that is perpendicular to the surface, and I have a downward gravity force. So that's the tension. Another force that you are going to see happening as well is called the force of a spring that is exerted on a mass once this mass is displaced from the spring position of equilibrium. So let's say the spring moves a certain quantity del x from its relaxed position. There is a force called the restored spring force, which is given by a number, by a constant, which depends on the spring material, how the thickness of the spring itself, the type of materials made, times how much of the spring is being compressed or distended. So if in our course the spring forces, or the force of the springs, will always be depicted this way. So we saw weight, we saw normal, we saw tension, and we saw spring force. So let's take a look at few examples. And try to find what is called FBD of forces, or free body diagram of forces. So which means I'll give you a physical situation like a ceiling and a block. So let's build the free body diagram of forces acting on the block. So you have to outline all forces that happen to be acting on the block. What are they? Assuming there is no air resistance and the block is pretty much in vacuum, there is always a downward force of gravity, Fg, that points it down. Right? It tries to bring the block down. You know that. If you let anything suspended in there, that thing is going to fall down. There is also an upward tension force, because I have a cord. I have a cord holding on to that block. So those are the two forces acting on it. If my block's not moving, I can tell once I establish a positive orientation that T minus Fg must be equal 0, because the block does not move with an acceleration, so T is equal Fg. Second situation, I have a block that is being pulled by a cord because it's attached to horse. Right? And then you ask, okay, what are the forces acting on this block? So you want to name all the forces on it. And later on, on Wednesday, when I tape this lecture again, I will solve problems. So right now I'm just trying to show you what are the forces and what are the orientations implied, and then later on we are going to learn how to solve that. So what are the forces on this system, on this block? I have the weight, always vertical and pointing down. Remember, now I have the block standing on a surface, so I do have a normal force. I do have a normal force. What else? Well, if the horse is pulling the block with a cord, I have a tension force here. So now I have a normal force, I have a tension force, I have gravity force, and if my block has no wheels and if the floor is rough, I have some resistance to its motion called friction. I have a friction force that is preventing the block from moving freely. So in this case, as long as I ignore air resistance, those are the forces that are playing some role in my block. I have friction, gravity, tension, and normal force. Okay? The last thing I would like to mention to you is the notion of friction, which I just indicated in one of my last example in there. So friction is a force that arises when you have contact between two surfaces and they might or might not move. Okay, I will give an example. Let's say I have a surface and I place a block on it, and the block is just standing there, right? It's perfectly horizontal, this surface. Now you might have had the experience of tapping the block with a forward force in an attempt to move the block, and the block doesn't move. Why? Because there is a frictional force that reacts to your tapping. That's Newton's third law. So if you were to describe what are the forces acting on the block, if you were to come up with your free body diagram, it would be a forward force that is exerted by you or me, F me, and there is a reactive called static friction, Fs, static friction, that matches the force that you exert on the blocks. So as a result, when you add those two vectors, F me minus Fs, you have a new resultant, meaning your block has a zero acceleration. The block doesn't move, it stays where it is. Okay? Now, there is an instance where you are able to overcome this friction force, and then the block moves. So when you get to this maximum value, when the static friction cannot hold anymore that motion, the static friction is found to have a value which is equal to the so-called coefficient of static friction times the normal force. We can determine this in the lab, that the maximum value of static friction that can hold on to a block or system or a car is equal to a coefficient that depends only on the materials used to build the surface, the one in contact, times the normal force that is being exerted on the object. Now once the block moves, Now you have the block moves with a given velocity, certain amount of meters per second. Why? Because you're pulling it to the right with a me force, F me, my force. When motion arises, so when, let me write, when motion arises, then the friction is not static anymore. So in static friction there is no motion. The friction is called kinetic. So we are talking about kinetic friction. And the kinetic friction is always equal to a coefficient of kinetic friction times, again, the normal force. So what is the main learning part of these frictional forces? Is that if there is no motion, the maximum possible value of a frictional force is given by this expression. But it could be zero if the static friction is a quantity that runs from 0 up to this maximum value. And I try to emphasize this in problems this coming Wednesday, and I hope to have some of you in the classroom. But once the blocks moves, the frictions are given by the value of frictional force is given by this expression. Okay?